Hi again. My name is Benjamin Friedman Wilson. I'm a software engineer with Tyfox, and I'm here to talk about Langium. In particular, in the last tutorial, we were talking about how to implement mini logo in Langium. We were just getting started with the grammar, as you can see it here, contained in this .langium file. So today, we're going to be going over how to implement validation for this language. Now, in particular, make sure that you've watched the last video, the Getting Started with Langium Part 3. This will give you an idea of what this grammar means, how it's expressing or capturing the notion of our language, which is mini logo, and just to kind of touch off a bit on it, we got the name of the grammar in here. We have our entry parser rule. We have various parser rules here. Parser rule bodies are fleshed out. We have a fragment that we can utilize to recycle some code. And we additionally have set up arithmetic expressions in our language, very simple arithmetic expressions, and maintained proper precedence by proper construction and ordering of the rules. So if you want to know more about this, please watch the previous video. That'll give you some more detail. It's very dedicated to that topic. But today, using this grammar, we're going to work on the validator. Now, if you set up your project using the human generator, you should have a project structure that looks a little bit like what we have over here. In this case, we have a generated folder, we have module, validator, Langium, and main browser main. Please note this is using the latest version of the generator Langium package on NPM. So we are now at 1.2.1. So if you have not already updated to this, that's okay. These tutorials should still be relevant, but just keep that in mind. If you want to follow along with the most recent version, you can always do a fresh install, and you can do that by starting at the first video and then going from there. So today, though, we're going to be looking at this validator. Now, right off the bat, it's pretty easy to see that we have an error right here coming from a file called ./generated/ast. And you may be wondering, what is this about? Well, if you were looking at the previous video when we had the hello world grammar still in our hello world.langium file, which is really a mini logo grammar, you can tell that this actually corresponds to a parser rule that we had called person. And in fact, yeah, we can see that it's not defined there. So where this parser rule comes from, though, as you can see, is not actually from the Langium file itself, but from the ./generated AST. So if we actually go into this folder and go to ASTTS, you'll see a file that you're not supposed to edit by hand. However, it's automatically built using the Langium CLI. In this case, as I mentioned, version 1.2.1. So this may be a bit much to read it first, but basically using interfaces and types and some other constants, we are able to capture the abstract syntax of your grammar, or as we like to refer to it, the semantic model. You may also use the term meta model. These are all three terms referring to the same general idea of capturing the essential structure of your parsed language. So we actually use this grammar to generate a parser in Chevrotain to actually recognize your language, and we have to parse it into some structure. And so this is the structure that we will actually be working with our parsed language through, or AST. It's called ASTTS, which is a bit of a misnomer. It's not actually the abstract syntax tree, but it is a set of types and interfaces that will allow us to capture the structure of any AST that should be expressible in our language, more or less. So going back here, we need to make sure that we first run a command that we actually ran in the last video called npm run langium generate. This will make sure that it takes our latest Langium grammar file and produces the requisite generated files, the whole folder's contents, in addition to our TextMate grammar, which you're familiar with. We also get a Monarch grammar now. This is a new change from the new version, but it's just another grammar language for use with such things as Monaco in the web. Just another language for capturing syntax highlighting. So, but if you see green here, as I mentioned before, this is the most important aspect. It means you've built successfully all your generated stuff. So the next thing we'll be able to do is actually build a project. However, this still doesn't work. We haven't really changed anything. And it works for a couple of reasons. One of them is because the generator is broken, but we're going to fix that at a later point. But another is because the validator is broken. So we're going to focus on the validator today. And you can see these errors match up with what we're expecting here. So one of the easiest things is that we can drop the import here and say we don't want to actually validate a person. We want to validate, let's think, we want to validate something else with our language. Let's say we want to validate, here's a good one. Let's validate defs. Defs exist at the top level of our language, at the model parser rule, which is the entry parser rule. So this actually is the top level node that we can expect in our AST. Now defs is going to be an array, and actually we can further verify this by going into here, looking up our model, and seeing if we jump to the type, the interface, we can see defs is actually captured as an array of definitions and array of statements as well are captured here. So again, the ASTTS matches with the structure that we're expecting to have corresponding to our grammar that we specified before. So now we know this is the case, we can actually write a validator to make sure that all of these definitions don't have duplicate names. That wouldn't make much sense, right? If we have, two different macros defined, two different definitions defined with the same name, wouldn't be able to distinguish them. So we want to actually add a validator rule for this. So we can change this one here to model. Notice that without changing any imports here, I'm not actually getting any errors. And this is because we have this hello world AST type, which in it has all the types in the AST that we can get. And so one of them happens to be, of course, model, which makes sense. However, here we have a problem. It's still going to be not correct since we need to actually import that type, but that's pretty straightforward enough. We can actually import it directly that way, and now we have access to it here. Perfect. So we can briefly explain too, or I can briefly explain what we're doing here exactly. So at the top level, we have these functions, and we have this class. Well, one function, one class. So this function, register validation checks, is just as you may suspect. It allows you to register checks, validation on types in our AST. The actual checks themselves typically implemented in this class, which you can change to some other name too. In this case, the default is hello world validator, which is perfectly fine, but we can always change it if we would like. So to register these checks, we actually need to get the registry. We need to get the validator from the services as well. We want to actually produce the checks, and in the registry, we want to put the checks in along with the validator. Now, the validator is important because if we don't have that, then we're not going to be able to actually perform the action that these checks do. And notice that this validator.check person starts with capital is defined under the hello world validator class. So that's how we get those validator checks in here. However, this body for this check doesn't really make much sense, actually. It's still for the person. So what we want to do is let's just comment this section out, and I'm going to keep it for reference, and we're going to rewrite it to do duplicate checking. So what we're going to do is get the defs, and actually we can already see right here that this isn't up to date, so we'll change person to model here for the variable reference, and we want the defs. Now we're okay if this is an empty array, we still know it's going to be there since we guarantee that exists. Now on this defs, we actually want to do a check to see if we have any duplicates, and in particular we have to ask ourselves if we're interested in checking and flagging as an error the duplicated definition or both definitions. So for this example, I'm just going to keep it really simple, and I'm just going to create a set of all previously encountered names, and if we see a name that we have already seen before, we just report an error for that. This is pretty simple, but keep in mind it won't actually report an error for the original. If you wanted to do that, you would need to actually collect all the names. For example, if you had like a multi-map, and then look for duplicates in that, and then report those. That's another way to do it as well, but we're just gonna keep it short. So we're gonna do, I don't know, previous names, new set, and we'll type this just to be explicit, and then we're gonna do defs, and we do for constant def of defs, and we do if previous names dot has def dot, and remember we have a name property that we set because if we go back to the grammar, our def has a property called name. This also has a property called parameters, and as you may expect, the name corresponds to something that was parsed using this ID terminal here, which in this case is just an alpha value, A through Z, upper or lower underscore, followed by some number of word characters or an underscore, any number. So we can take advantage of this right here and actually just check to see if, well, we have this unique identifier present. If we do, then we're going to use this error here, or this acceptor, which allows us to accept validations of various types, not just a warning. We can also do error. You can also give hints and info as well, but we're really interested in that warning one. And we're going to change and say, let's think about what we want to say here. We could say definition cannot redefine an existing definition name. And then we want to correspond where this error actually shows up, because this will be in our editor. We're going to see this, and we want to change it to the corresponding node. So we'll do def, and then we'll say which property it shows up on. And there's a few properties that we can have for our definition, and we just want to use the name property. Now the name property is going to, of course, highlight the name of this definition. So this will make it pretty simple. There's a few other choices here, but this makes it a pretty safe thing. So now we have this present, and we can go ahead and safely delete this. You can also keep it if you want to actually do a check here. And in this case, our language is case sensitive actually for writing it this way. So another thing, if you wanted to do, oh, we're also not done. Oops, we want to actually do previous names dot set def dot name, just to make sure that it is in fact just to make sure it's there. And if we wanted to actually make it case insensitive, then we would do maybe something like 2 lowercase, and then here we'd also check with 2 lowercase. And we could do locale lowercase as well, but we'll just keep it lowercase. Cool. And there we go. Now we actually have a nice little error, and we have a way to check it. And we could also do the same thing for a few other parts of our language as well. And also we should really change this validation. It's not really very clear. Let's do check duplicate definition. Let's actually do check model, because really we're doing a check on the model, and we happen to be doing a duplication check here. So check for duplicate def. And in theory, we could also do some other checks here on the model. We're not restricted to doing just this. We could do further checks as well. So for example, if you wanted to do an additional check on, say, what's a good example? The parameters contained in a definition, because parameters, if you look down here, they do have a name, and it may not make sense to have a definition that has parameter x and x. So let's add that really quickly too. So we'll actually show an example here of how to add a fresh validation. So in this case, we know that it's going to be called def is our actual AST node we're interested in. Let's do validator dot check def. It doesn't exist, but we can add that in. Check def, and it's going to take a instance of a definition. We're going to want to import that type. It takes a validation acceptor, and it returns nothing. Let's do a quick import. There's our type. Oh, also I just realized this is probably really annoying with this base here. That is an error, so let's just close that. And let's go ahead and do actually something really quite similar to this. So let's just be cheeky and just comment or copy this whole thing over here and do def dot params. I mean, they even have the same property really, and we just change this to be, instead of def, we can say params. Still can use previous names, and we want to change this to param. And yeah, now we can say, I don't know, let's change this to be duplicate parameter name. And then actually, let's make this a template string, and let's be more explicit here. Let's do duplicate parameter name. And then let's actually show param.name, not the lowercase version. Let's just show the uppercase version, and then maybe put it in single quotes here. Cool. Yeah, so now we have 2 validations, and if we really want to be nice about it too, we could also add some function headers or method headers here. So just checks definitions for duplicate params, and then yeah, we can fill these out if we want, and then also same for model. Check model for duplicate definitions. And that's that. So now we have these validations here. These will allow us to perform some integrity checks on the actual finalized parse structure of our language, which is fantastic. And we can keep going, we can keep extending this as we want to go. And so now, just to be certain that we've actually addressed these errors, remember, it's not all the errors, it's just these 2. I know it's a shame it's not all of the errors, but it will get us closer to what we want. So we can build again, and we should see only 4. We had previously 6. So we got 6 here, and here are the 4. So great, we just knocked out these errors. Okay, so that is how you implement very simple validation checks into your language. In practice, it's good to do the checks as directly as you can. For example, I could be checking definitions inside this model check by actually doing a validation on every previous definition as well for all the parameters, but makes more sense to define this in terms of definition. However, it does make sense to define for duplicate definitions at the high level because they're contained within the model. So you can use your best judgment for your language to define a set of checks at the right level to be checked. Okay, this video is coming up on 20 minutes, so I think I will cut that here. Thanks for watching, and next time we are going to move forward and proceed with let's decide what we're going to fix here. We have some issues with the generator and the modules, so really let's see if we can just fix the rest of these issues in the next video and actually get our language building so we can actually see the CLI work. So yeah, that'll be next time. We'll be talking about finishing the generator here, just getting the bugs worked out and cleaning up the rest of these errors to build our Langium based language. All right, thanks again, and we'll see you in the next video.